Welcome. In this video, we'll be solving trigonometric equations involving cotangent part 2. Let's take a look at our first example. Solve the equation given below for theta greater than or equal to 0, less than 2 pi. So notice here we have square root of 3 is equal to cotangent of theta plus 3 pi over 4. So the first thing we're going to do is to introduce a new variable. Let alpha be equal to your theta plus 3 pi over 4. Now, that new variable will allow us to rewrite this original equation as the square root of 3 is equal to cotangent of alpha. Recall that cotangent is the reciprocal function for tangent, so we can rewrite this equation as follows. Square root of 3 is equal to 1 over tangent of alpha. And using the reciprocals of both of these two sides of the equation, we get 1 over square root of 3 is equal to the reciprocal 1 over tangent of alpha, which is just tangent of alpha. Now, we don't want to have any square roots of 3 in the denominator because that's an irrational number. So we need to rationalize this denominator. To do so, we can say, well, we have tangent of alpha is equal to 1 over square root of 3. And let's rationalize this by multiplying by square root of 3 over the square root of 3. So this becomes the square root of 3 over the square root of 9, and the square root of 9 is 3. So we take tangent of alpha to be square root of 3 all over 3. Now we're looking for any angles, and using the fact that a tangent has a period of pi, so we want any angles between the 0 and pi that will give you a tangent equal to a square root of 3 over 3. So in this case we have square root of 3 over 3. The corresponding angle on that interval is pi over 6. So we get that alpha is equal to pi over 6. Now using the fact that alpha is pi over 6, let's solve for theta. So we have that theta plus 3 pi over 4 is equal to pi over 6. And how do I know this? Because that's exactly how I define alpha to start off with. Now let's solve for theta. To do so, let's subtract the 3 pi over 4 from both sides of the equation. So that implies that theta is equal to pi over 6 minus 3 pi over 4. Now let's get the common denominator, which happens to be 12 here. So let's multiply this one by 2 over 2 and this particular expression by 3 over 3. So we get that theta is equal to 2 times pi minus 3 times 3 times pi is minus 9 pi all over 12, which gives us negative 7 pi over 12. But notice that theta is not on the interval from 0 to 2 pi. So what we're going to do is to use the fact that our function here, our function in terms of theta has a period of the regular period of tangent, which is pi, over the absolute value of the coefficient of theta, which is 1. So really the period of this new function is pi over 1, which is just pi. So we're going to add that period to this particular angle to get another angle. So our theta now becomes negative 7 pi over 12 plus pi. Now let's multiply this pi by 12 over 12 to get the same denominator. And we get, negative 7 plus 12 becomes positive 5. And of course we have the pi all over 12. So this is one of our solutions here. To get the other solution, what we want to do is to add another period of pi. So we take the next theta to be 5 pi over 12 plus pi. Once again, let's multiply this pi by 12 over 12. So we have 12 pi plus 5 pi now becomes 17 pi all over 12. So we can say that our solutions for this equation are theta is equal to 5 pi over 12 or 17 pi over 12. Let's take a look at another example. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. So we have negative 3 minus a fourth of cotangent of theta plus 3 pi over 4 is equal to negative 13 over 4. So let's isolate the cotangent. To do so, let's go ahead and add a 3 to both sides of the equation. So we have negative 1/4 of cotangent of theta plus 3 pi over 4 is equal to negative 13/4 plus 3. Now let's multiply this 3 by 4 over 4 so we can have the common denominator. So we have negative 1/4 of cotangent of theta plus 3 pi over 4 is equal to negative 13 plus 3 times 4 is 12 all over 4. So in general, what we have is the following. We have negative 1/4 of cotangent of theta plus 3 pi over 4 is equal to negative 1/4. So let's get rid of this negative 1/4. You can multiply by negative 4, or we can simply divide by negative 1/4 on both sides of the equation. Now this cancels, so we get that cotangent of alpha, or I'm sorry, theta plus 3 pi over 4 is equal to the same number divided by itself becomes 1. Now here we have cotangent. Well, recall that cotangent is the same as 1 over tangent, so we can rewrite this one as 1 over tangent of theta plus 3 pi over 4 is equal to 1. So what we're going to do is to get the reciprocals of both sides of the equation here. So the reciprocal of 1 over tangent of theta plus 3 pi over 4, it's simply tangent of theta plus 3 pi over 4. And the reciprocal of 1 is 1 over 1, which is still 1. Now at this level, what we're going to do is to introduce a new variable alpha. So let alpha be equal to theta plus 3 pi over 4. Thus, this equation becomes tangent of alpha is equal to 1. Now, tangent has a period of pi. So let's find any angles between 0 and pi that will be giving you tangent of 1. So let's take a look at their chart. Notice that that particular angle happens to be the pi over 4. So we know that alpha is equal to pi over 4. Now, extremely important to us is to use that particular value so we can solve for theta. So using alpha is equal to pi over 4, now let's solve for theta. Well, we say, well, instead of alpha, we can write theta plus 3 pi over 4 is equal to the right hand side, which is pi over 4. Now let's isolate the theta. To do so, let's go ahead and subtract the 3 pi over 4 from both sides. And we get that theta is equal to pi over 4 minus 3 pi over 4. So this now becomes theta is equal to 1 minus 3 becomes negative 2, obviously pi all over 4. Let's divide both numerator and denominator by 2, so we get that this is negative pi over 2. However, notice that this is an angle that it's not on the given restriction for theta. We want theta to be between 0 and 2 pi. So what we need to do is to add the period of pi to this particular angle. So our first theta on that particular interval now becomes negative pi over 2 plus pi. Let's multiply this one by 2 over 2 to get the same denominator, and you end up with negative pi plus 2 pi becomes pi all over 2. So that's your first angle here. Now to get the next angle, we take theta to be pi over 2 plus the period of pi. Again, let's multiply the pi by 2 over 2. So we can get the common denominator, and now that becomes pi plus 2 pi becomes 3 pi all over 2. So that is your second solution here. Therefore, we can say that the solutions for the original equation are simply theta is equal to pi over 2 and 3 pi over 2. So that concludes this particular video on solving trigonometric equations using cotangent part 2. Thank you for watching and have a wonderful day.